So good morning, good afternoon, everybody, and welcome to our session today. My name is Ian Gillett from IGR. Today, we're going to be talking about enabling innovation with 5G and CBRS. We're doing this with the 2030 project, which is a company we started earlier this year to start looking at new technologies, digital infrastructure, private networking, and some of the implications for the enterprise as a whole. So in terms of the speakers, my name is Ian Gillett. As I said, I'm a market researcher. I live in Austin, Texas. And with me today is Caroline Chan. And Caroline is VP, she's a long title, VP Data Platforms Group and GM Network Business Incubator Division for Intel. So I'm going to kick things off for a few minutes and kind of set the stage in terms of what 5G is, what CBRS is. Caroline's then going to talk about some of the applications, use cases, and kind of how 5G fits into the bigger picture, and then we'll wrap it up. So the first thing is to look at the picture as a whole of what is 5G and how does it support different industries, consumers, etc. This picture here is really of a metro area as we see it in probably 5 to 10 years' time. Some parts of this are enabled already. But if you look at this, what you can see is obviously a lot of cars and vehicles running around. If you look on the right-hand side there, you can see the home, and there's a yellow area around the home, which is 5G. So 5G is being deployed today. It's available in different markets, depending on where you live. But 5G can provide high bandwidth services to the home, obviously while you're out in a mobile environment as well. You'll also notice at the stadium at the bottom there, putting in 5G in a stadium. It's very popular, provide high bandwidth services within the stadium. It could also be in manufacturing plant or logistics, transportation, etc. And the one, of course, we're interested in today is for agriculture, which I've put there just at the top left. So everything we talk about today, when we talk about an enterprise, we talk about 5G, it applies to the agriculture environment as well, to a farm, etc. So having control for different drones, applications, sensors is all possible today and is being deployed today. And that's what we want to talk about, is the ecosystem that enables this and some of the case studies for that. Now, this picture is going to take a while to develop, obviously. If you notice, there's like a big blue shaded area over the whole thing, and that is the overall 5G network. So everything that we have today for 4G, LTE, will be upgraded to 5G over time. Just as we move from 2G to 3G and 3G to 4G, so now the industry is going through an evolution that will impact all consumers and all businesses over the next few years. And obviously, some of you probably already got 5G devices already. Now, next we need to talk about CBRS. And CBRS is very interesting and enables a lot of different applications and different services, but allows you to do that in an enterprise environment without the need to work with a mobile operator. So CBRS was actually envisaged about 3 or 4 years ago by the industry, and the FCC's worked on this. And what they've done is basically take 150 megahertz of spectrum in the 3.5 gigahertz of 3500 megahertz band. It's called mid-band spectrum. It's very appealing. The signals have pretty good penetration. We'll talk about signal strength in a second. They can go quite a distance, but also you can get good capacity on that. And 150 megahertz is quite a big piece of spectrum. Now, what's happened is, and I won't go into too much detail here, but what the FCC has done is said that you can use CBRS. You can buy a CBRS radio, you can take it and plug it in and build your own private network with that. You can have what's called a priority access license. Those were auctioned in the summer if you want to have some priority dedicated access. But also there's a big chunk of shared spectrum as well. But the trick with CBRS is, because you're probably thinking right now this sounds a lot like Wi-Fi, is that CBRS uses LTE, which is the same as 4G. So LTE gives you a lot of good security, policy control, management of the network, etc. So an enterprise now using CBRS can go buy CBRS LTE radios, connect to an LTE packet core, the back end of the network, which you can get from a hosted provider in the cloud, and build your own private network. iPhone 11 was the first iPhone to support CBRS. Other devices support as well. There's a myriad of cameras and sensors and modems, etc., to support CBRS. So the ecosystem is growing quite nicely right now, and there's a lot of networks being deployed and different use cases being demonstrated. And Caroline will talk more of this in a minute. So if you're a farm today, and you're thinking, okay, I want to have my own private network. I want to have my own network for IoT or for monitoring crops or whatever it is. You have the choice of going to work with a mobile operator, or you have the choice of actually going building your own CBRS network and actually building your own network using the CBRS spectrum, and obviously doing that without the need to involve AT&T, Verizon, T-Mobile, etc. Now, the next slide is, I need to get a little bit more technical here, and this becomes very important, especially when we're talking about outdoor applications such as with agriculture. So the CBRS radios, there are two types. They call them Category A and Category B, which is not the most original name. But Category A are indoor small cells. They're designed for use indoors in dense urban areas, and the power is limited on them, so the range is limited. Category B is for rural outdoor applications, and those applications those radios, actually, the signal strength is much stronger. It's actually closer to the signal strength of a regular cellular network you get out in rural markets. So putting in a Category B CBRS radio, you can have a signal that can go for a couple of miles. So covering a large area of a farm, for example, can be done with relatively few radios. Obviously, the exact number is going to depend on how big the area is, the topography, the application, et cetera, But this is not something, Category B radios are more powerful, for example, than Wi-Fi. So if you're thinking, well, I couldn't cover my farm with Wi-Fi, will CBRS work for me? The answer is yes. It could actually provide that level of coverage because it is a higher power network for that area. Now I'm going to pass to Caroline Chan from Intel, and she can talk a little bit more about the ecosystem and some of the case studies here for 5G and CBRS within agriculture. Caroline.
Yeah, thanks, Ian. So first of all, I wanted to just give a real quick overview of what Intel plays in the role of a 5G ecosystem, because you probably know us as the laptop guys, the CPU folks, the server guys. But in reality, Intel actually powers the 5G, especially the network and the IoT sensor side. Intel has a group that we're really focusing on providing the silicon as well as software, enabling software platform for the 5G networks. We currently slated to be the #1 silicon vendor in the 5G, especially in the radio access network. So what you see is that we touch points all the way from the access portion, so the radio, the edge of the network, the core network, of course, and the cloud. But what I really wanted to talk about, what is the farm of the future? Today, I think you emphasized that the farm, sometimes you have Wi-Fi and connectivity is not consistent. What we try to do with the CBRS and the 5G is to provide always-on connectivity. And in order to connect all the the equipment you have, providing the control, the precision agriculture. And I've always said, you heard me many times, connectivity is an enabler, it's not the end. The end is how well you will run your agricultural business. It's always measured by the return of a business. We look at the farms, I mean, just the United States alone, the number of farms and the square miles and the criticality of a stable, secure food supply chain is so paramount to our society. Is evident from all of the government discussion about the grants that's made available to precision agriculture. To that effort, that Intel has joined a whole group of ecosystem. I just want to talk about two particular ones today. The first one I want to talk about is that we are part of what we call the Rural Cloud Initiative, RCI. It's a group of operators and OEMs, and we're providing, actually the cloud service provider is also part of it, is to provide a cloud, a low-cost shared cloud with connectivity that's serving the rural carriers. The example that we're showing here today is a greenhouse, a very large granary, Hearst in Westboro, Missouri. So today, on September 30th, we launched a private LTE network for the greenhouse. It has deployed a network platform. It's virtualized. It runs cloud native. It's managed, automate all the temperature control. We're in the mix of launching a phase 2 that we would, and 3, we're providing all the innovations of machine vision solutions, crop tracking, inventory monitoring, and then eventually the phase 4 will be connecting all the devices together. In fact, at the board level, we're discussing around mid-December, we'll have a open house, inviting a lot of the partners nearby to come in and see it. And the initiative itself, like I mentioned, has quite a few of the rural carriers involved. The initiative also has a joint collaboration with the second ecosystem that I wanted to mention, which is driving the innovations. If you look at this, like everything that Ian talked about, once we provide the connectivity, you want applications, you want developers to come in and write applications to provide all the precision control for you, and enabling a lot of the machineries that's already and will be rolled out in a farm, and connect that to the cloud. And don't forget that, because a lot of what we talked about is running on the edge. A lot of the information that you gather at the edge is only contextual at the edge. By the time you get back to the cloud, it may no longer be relevant. So we wanted to be able to run a lot of analytics in real time at the farm, and then bring back the relevant data to the cloud for learn and training purposes. So with that principle in mind, we Intel is set out to work with many of the partners to implement this type of edge cloud and the cloud connected by 5G, and with many of the applications actually running on the edge. So another use cases we want to talk about is a secure supply chain. As I mentioned before, we're part of the what we call 5G Open Innovation Lab in Seattle, that's co-founded by Intel, T-Mobile, Microsoft, Dell, VMware, MDOS, and NASA. So we run through about 2 cohorts a year. The latest cohort, we have a company based in Seattle that provides sensors to track all the critical food supplies along the way. So make sure that the food that delivered to the stores are secure, has tracking all the temperatures, and making sure that there's none of the issues that we see, either food rotten or having any kind of issues involved. So very, very critical to that. Another use cases that we are actually doing is a tomato greenhouse. This is another one that using the Intel RealSense cameras for 2D, 3D images, using the private network 5G CBRS going up to the network, and using edge servers that powered by Intel CPU, similar to all the servers you have in the cloud, to run AI and machine learning at the edge. Visualize all the data, controlling all the temperatures and soil and stuff like that, in order to improve the productivity of the tomato greenhouse. So you can see that a lot of these things that we're doing is really harness couple of things. Number one is the edge, the fact that you have now edge compute all the way through at your farm, controlling the soil temperature, disease control, and all of that information, and using the power of the network to take the relevant information to the cloud. And also, there's a lot of cameras being available, a lot of AI and machine learning technologies. This is just a sample that what we're doing today as an early pilot. But because of the fact that we're able to unite multiple elements in the ecosystem, the network, the analytics, the cloud providers, and most importantly is the power of all the developers out there. We're confident we're able to create this end-to-end ecosystem that will fully harness the power of 5G and CBRS and all of the compute the edge can provide. So back to you, Ian.
Thank you, Caroline. So you can see how my general picture of a metro market with the 5G, CBRS connectivity, the different applications, the different vertical markets, taking those capabilities of sensors, security cameras, video analytics, edge compute, putting it all together, you can come down to some very specific applications, such as supply chain or something, tomato greenhouse. And obviously that tomato greenhouse could be applied to different crops, could be applied to different scenarios, it could be applied to livestock just as easily with the same or similar application. So when we put all this together, what does all this mean? So firstly, the thing to take away here is, number one, is enterprises can deploy their own networks without the need to involve a mobile operator. Caroline mentioned some of those case studies that they are working with operators, and there may be advantages to doing that, but you don't have to get the operator involved if it's not necessary. An enterprise is not just a manufacturing plant or a warehouse. It is a farm. It could be a greenhouse operation. It could be a dairy farm. So lots of different applications there. The ecosystem is available today to support this deployment. You can go and buy radios today, CBRS radios. You can connect up to edge compute. You can connect to a packet core. You can connect to the cloud. There are systems integrators can bring that all together and work with different application vendors. And the CBRS spectrum that I mentioned is available today. It was actually made available back in January. In the US, and it is across the entire US. And again, you can buy the equipment and the services today for that. The big thing as well is the private networks deploying using CBRS do use LTE 4G. It's the same LTE you have on your iPhone or your Samsung Galaxy, your Android device. And just as those devices are upgrading to 5G, so CBRS will upgrade to 5G as well. It's not a case of investing in equipment today and having it become obsolete in a couple of years. The vendors do have upgrade paths and the ways to upgrade if and when is needed. Not all applications need 5G. There are lots of advantages to 5G, but there's many different things you can do with LTE and edge compute, for example, today. CBRS, as I mentioned, supports those radios with sufficient power to cover a wide area, square miles, large acreage. You can deploy it to cover a farm. Farms actually have an advantage. If you've got a grain silo, it makes a really good cell tower. Putting a radio on top of that tower, you're going to get some coverage there. The signal's going to go for quite some time, quite some distance. And again, it's going to depend on the topography. But the equipment is available today. This is not just using Wi-Fi. It's more than Wi-Fi. As Caroline pointed out as well in her case studies here, the value is not just in connectivity. The connectivity results in innovation. It's IoT, it's the smart applications, it's the autonomous control of vehicles, it's monitoring those crops or livestock. It's taking that data, using the connectivity to deliver it to a compute resource at the edge or in the cloud and running analytics on it and taking action. And so all of this enables a large ecosystem of agriculture developers. We actually started building a list of all the developers out there who've got different applications for agriculture. And it's a big list. There's a lot of people looking at this saying, I've got this connectivity, I've got the compute power, I've got the cloud, I've got the sensors, the cameras, what can I do with it? And the final thing is the solutions are now. These case studies that Caroline talked about, are real. This is not something that's we're gonna have to wait 5 years for. This is something that can be done today. You can put in LTE using CBRS with edge compute and the cloud and build a solution today. Finally, I'd say if there's any questions after you're reviewing this, if you have any questions for Caroline or myself, feel free to reach out. I'll be happy to talk further. Thank you.